大家晚上好，今天的论坛即将开始，请大家有序入座。Ladies and gentlemen, may I have your attention, please? The forum will begin shortly. Please take your seats. 尊敬的各位来宾，大家晚上好，欢迎您来到第50届孔子博士论坛。本次论坛由于爱尔兰中国研究院和 UCD 孔子学院共同举办。我是本次的活动主持人陈素怡。在论坛开始之前，请大家将手机调至静音或关静状态，以便营造良好的听讲氛围。Good evening, ladies and gentlemen. Welcome to the 50th Confucius PhD Forum co-organized by the Irish Institute for Chinese Studies and the UCD Confucius Institute. My name is Sui Chen. I am your host tonight. Please allow me to give our sincere welcome to all of you. Now, before the forum starts, I kindly suggest that we mute or turn off our cell phones to create a good listening atmosphere. 本次论坛分为3个部分。嘉宾演讲、提问环节以及会后的中餐自助。The forum is divided into 3 parts. First, we will have a lecture given by Professor Shen, and you can have a little discussion with Professor Shen and ask some questions after this. We invite you to join us for a special prepared Chinese buffet ever. 那么接下来便正式开始我们的孔子论坛。首先有请都柏林大学孔子学院王礼明教授、院长致辞。
Okay, good evening, everyone. As the director of Irish Institute for Chinese Studies at UCD and the UCD Confucius Institute, I would first extend my warm welcome to all of you to attend today's public lecture. It is a great honor for me to introduce our distinguished guest, a speaker today, Professor Sanbing. So he is currently the Associate Director of the Confucius Institute at the University of Galway. But your name, Confucius Institute name is very long. I tried to, do it right. So the Confucius Institute of Chinese and Regenerative Medicine. Okay, that's good. So that's his hobby. No, it's not his job. This is just his job. He's paid as the professor of fundamental stem cell biology at the Regenerative Medicine Institute at the Galway Medical School. So that's his real job. Like me, my director of the Irish Institute for Chinese Studies is my job. I'm paid for that. My director of Confucius Institute is hobby. It's not really my job. Okay. Professor Shen actually got his Bachelor of Science in genetics from Zhejiang University in 1983, 40 years ago. Okay. MSc in development biology, right, from the Chinese Academy of Natural Sciences in 1986. Right. And 20 years ago, in 1993, he completed his PhD at the Royal Netherlands Institute of Development Biology. Right. Since then, he has been working in the UK and Ireland at various institutions, include University of Aberdeen, Edinburgh University, of course, University of Galway. So Professor Shen has a long list of appointments, internal, external, grant awards, and more than 100 peer-reviewed papers, and with 15,000 citations. How could you achieve that? As an academic, I admire your achievements so far. So I only got his CV this afternoon. So when I look at his CV opened on my screen, oh my goodness, 24 pages, single space, all right? Single space. So that would take probably a long time for me to go through his CV, but you can find it anyway from his homepage. So another thing I also share with the audience here before your lecture, I tried GPT today and search before I received the CV, search Professor Sanbing at Galway. And yeah, I got a result. I will share with you something wrong there. But anyway, so it's just try to test the accuracy of the chat GPT. Not really accurate against his CV, of course. I think it's more importantly, Professor Shen and myself, we have been here as colleagues in different universities in Ireland. Ireland is not that huge country, so we have been knowing each other, being a very good friend to support each other for more than 10 years, right? So I think we are privileged today to have Professor Shen delivering a lecture on the topic of human stem cell and genome editing for Chinese medicine. So I expect your lecture on that topic, although I'm really know nothing about it. So now, without further ado, let's welcome Professor Shen.
Thank you very much, Li.
So you have that.
Thank you, Mario, and thank you, Professor Li, and for the warm welcome and the invitation. It's my pleasure, always my pleasure, to come here to UCD to visit the Confucius Institute. And this has been my, how many times? I can't remember, probably 8 or 10 times visiting the Confucius Institute. I love this building. I love people here. And so I, let me see, can come out of this, share, stop sharing. And then this one, okay. All right.
Probably should share the slides. Share the screen. Screen share still.
The screen. Yeah, the share is on. So, yeah. So what I'm going to talk is something is relevant to you, which is Chinese medicine. Why I say Chinese medicine is relevant to you? Because Chinese medicine is a part of Chinese culture. So human stem cells is my job. So I'm professor of stem cell biology. Gene editing is the new technology I have been learning in the last a couple of years. So I'm trying to combine this together. So this is not a normal seminar, like, tell you what we have achieved. It's rather than a proposal, what we can do together in the future, if you're interested. So Chinese medicine, and including 3 elements, parts 3. You have herbal medicine, and you have acupuncture, and you also have Tainan. And this has been benefited Chinese people for over 5,000 years. And why I say so, because actually I'm a little bit embarrassed to say so, because I didn't know. And I didn't know this before I prepared this lecture. So don't feel embarrassed yourself. And because I'm embarrassed, when I look into the history, and we all call, as a Chinese person, we all call ourselves Qian Huang Zishen. And then now, Xian Emperor, and has tasted, if not hundreds, would be thousands of herbs, then identify probably 350 herbs, recorded, and what's their effect to our health. So for the herbal medicine, it can be backdated to more than 5,000 years ago. For acupuncture, again, it's backdated to Huang Empire. And actually, what I found out was Professor Li and Huang, and they have done many years of translation on Chinese medicine, and they know more about this if we are interested to communicate and in this area. And there are many, many well-known Chinese doctors in the history of Chinese medicine. I'm not going through and what they have achieved, but you can have the slides. If you're interested, you can study more on that. Come back to a personal experience. I was in Scotland for 18 years. I invited my father to visit me and stay there for half a year. And I took him around and in England, in Scotland, and we even did camping. And one more, he always got up early in the morning for breakfast. And one morning I say, hey, Dad, breakfast time. And she said, sorry, I can't get up. He developed a sciatic nerve pain, so painful she couldn't get out of bed. Then, and my friend and the Dr. Liang and found out, and he graduated from a Chinese medicine university in Zhejiang. And he came to my home, did acupuncture, and together with Jiu, and you know Jiu and where it's coming from, and it's in the next one, an important molecule in the herb too. After 3 weeks of acupuncture, eventually we made an appointment to a consultant in hospital. And the consultant was really surprised. What have you done? I have never seen a person recovered so quick, because he was walking in hospital. My father is 95. This is a picture, and not long ago, just over 2 weeks ago. And he never had this problem again. So that shows how effective and how I was educated on acupuncture, on Chinese medicine. This young man is Timothy O'Brien, and he is the director of the Confucius Institute in Galway. When he was a medical student in 1982, he witnessed a surgery because the patient, the elderly patient, had hernia surgery, but allergic to anesthesia. So it was acupuncture as a replacement for the surgery. And he was so astonished. He kept mentioning this to me again and again in the last 10 years while I was working with him in Galway. I think it's a good opportunity to develop Chinese medicine together for the benefit of whole world. And this is just to say the first Chinese Confucius Institute was opened by Xi Jinping in 2010 in Australia. And then and this is a major policy in China, kept mentioning again and again for so many years, and still it's a priority to inherit, to develop not only Chinese medicine, but integrative medicine of Western and Chinese medicine for the benefit of whole humankind. And we are inspired, really inspired by the Nobel Prize. And this Nobel Prize was given to Yu Tu, who discovered a molecule called artemisinin. Artemisinin is from a herb, and we use that herb in the countryside, and we smoke it and to keep a mosquito away. And it is from this herb and this molecule was purified, which has saved millions and millions of people from malaria in the whole world. The question we ask is, in the herbal medicine, are there more molecules there to identify for different human diseases? But what you know and you don't know is the drug discovery has been not very successful in the last decades. Company investment, the investment in an exponential way, but the drug output is not in proportion to the financial investment. As a result, many companies, they stopped code research and development, R&D. They used to employ a lot of people to do research in drug companies. But now, they have a new department as a replacement called S&D, Search and Development. Search and development, they just look through the literature, what's the discovery and what have you got, can I buy? Why? Because we do a lot, they do a lot from disease modeling to phenotype, to drug screening, to animal model test for the drug efficacy. From there, if you test 10 or 100 molecules in phase 1 clinical trial, less than 10% are coming out as FDA approved drug. More than 90% of drug development and went to the drain. Why? We often ask why. Now here is one of the examples, if I may convince you, one protein, transmembrane protein, activated by neuropeptide. Before those amino acids, because those amino acids, the difference between mouse and human, what's the consequence? A pharmaceutical company in California screened 1.67 million compounds. They identified one molecule which is effective to human as an antagonist, but that's completely inactive to mouse protein. You may say, that's great. You got a compound specific for human protein. Yes, that's right. But if other way around, as we normally do, go for the animal model and animal protein, animal cell to start with, eventually come to human clinical trials. Doesn't work at all. That shows human disease models are very important. But what's the problem? The problem is I say, all right, you can take my heart. You can screen for drug. You tell me I can't grow your heart. If I give you my brain cell, you say, sorry, I can't grow your brain cell. Which is the conventional cell culture, you can't. But the technology on stem cell biology now makes this possible. So Timothy O'Brien came back from America after 30 years, started a regenerative medicine institute on basic research. Not right leaning to build this building, 40 million. Then to also and have GMP stem cell manufacture, which is another 20 million, just for internal refurbishment and the licensing. And then a translation facility in the hospital, so that he can take patients into this new building, another 40 million, and produce a stem cell in the GMP facility and do clinical trials, how stem cell may help us to treat diseases which are not able to be cured with current drug. This is the majority of people focusing on the adult human stem cells, how they may benefit, and we may benefit and from for different diseases. And then he got me. He said, "Sanbing, come to Galway." What he asked me is fundamental stem cell biology. So what I proposed is the complementary model of area of work rather than doing the same thing, repeating their work. I said, all right, I'm going to start a new area of so-called induced pluripotent stem cells. What is that? If I give you a skin punch, you can grow fibroblasts on the culture dish. Then you put 4 Yamanaka factors, so-called, because that's Nobel Prize technology again. Then a few cells can start to grow like embryonic stem cells. They keep growing. And then if you purify those cells, it's going to be pure stem cell. They are just like embryonic stem cells. They can become any cell type you want: brain cells, heart cells, beta cells, or gut cells, or skin cells for transplantation, or immune cells to kill cancer. So now, after 10 years, and we have a biobank, recognizing a biobank of stem cells, human-induced pluripotent stem cells from 100 people. For a small lab, this is a huge resources. What can we do? They are coming from healthy control. They're coming from people, children with autism, and people with epilepsy, with the neurodegenerative disease, ALS, and with blindness, and with longevity heart disease. We can use them for disease modeling. How to do disease modeling? If I'm a patient, you compare if I have brain and disorders. You make neurons, compare my neuron with your neuron, and to see why my neuron is not working. And we can make a beta cell for diabetes. We can make cardiomyocytes for heart disease. We can make neurons and for brain disease. While doing disease modeling, we can also try to add drug into the cells to see what difference can they make. This is coming to the drug screening. So to enable connection to Chinese medicine, and we visited China. I visited China with Timothy O'Brien many times. In 2019, we visited together 5 times. So we visited the Nanjing University Chinese Medicine, and we talked with them, and we come to an agreement, and we visited hospital, and we will work together. And this is supported, and without government support, without Irish embassy, Chinese embassy, and Hanban support, without friends' support, this is impossible. I still remember what Li Ming told me on the phone. Li Ming told me in Chinese is 3个臭皮匠顶个诸葛亮，算我一个。Count me on. I'm one of the 3, and who is going to make this possible? And we signed the agreement with Hanban on 27 February 2019, and then the 3 and the staff and from Nanjing and came in November 2019. It's a small Confucius Institute, very small, but we have a very big ambition. What's the ambition? Hanban say you must do Chinese education. Is all Confucius Institute. So we have to take this on. Although West Island, Galway, is a very small area with limited population. But if you want to really learn Chinese medicine, this is a must. Yeah. And we want to improve the clinics, and also because the Chinese medicine and it's not standardized. Every country is different, policy is different, and the requirements is different, education is different. Can we influence Irish Chinese medicine practice or beyond? So we would like to develop WHO training here in Galway or in Ireland, as well as where maybe one day master degree on agriculture. And we want to do research. This is unique. We want to combine stem cells with Chinese medicine to identify effective molecules and specifically effective for humans. And we want to build a global alliance of Chinese medicine, or Confucius Institute on Chinese medicine. So for global alliance, we first proposed this idea during the signing, and then we visited and in September on September 18, 2019 again, and we submitted a formal proposal, and then in the meeting we had it together and with Li Ming in Changsha. I was very brave. I went to the because they built the Chinese alliance of partner university. I wasn't invited, but I asked, can I be there? And I made an announcement. We will set up global alliance. And I told them, we are new, we are young, we are small, but we are ambitious. And we got resources which everyone are welcome to collaborate, to work together. And eventually, because of the COVID, we set up this online, the first global alliance, and again on 18th September 2020. And since then, we had every 2 months we have seminars about Chinese medicine and so on. So we are going to have first face-to-face meeting in August and this year for the Global Alliance. We haven't decided exactly program yet, but what is the research component we want to do? The research component we want to do is we want to exchange resources. I will send a stem cell to China. I want to take a library molecules to Galway. We do research together in China and in Ireland to make best use of the resources. So that's the idea. But then you say, how are you going to screen molecules? And I said, right, look, we have a Nobel Prize again, 2020 in chemistry. We can make use of this technology. What is this technology? This technology is enable you to come in any place you want. You say, why do I want to cut it in it? That's destructive. But then, of course, after DNA is cut, we have a repair system. And this repair system, either with arrow, yeah, you can have deletion, you can have insertion, but you can also make a change in the way you like. You may say, now, and on this narrow road of Chinese medicine and the code of genetics, there were so many Nobel Prizes already winner. Discovery of the DNA double helix structure and the DNA polymerase to synthesize DNA, to sequence whole genome technology, and then to cut, that's the scissor, restricting enzyme to cut. But they only cut about 6 base pairs, recognize 6 base pairs, not 20. It will cut everywhere in the genome. And then, make a specific change in the place you want, or amplify DNA in the test field, or make knockout or changes in the genome, make mutants, make animal model together with the stem cells. But all these are tedious work, time-consuming. And this is my own work. 6 models, 18 years. But what can this technology now bring us? It will enable in a few weeks to make a new mutant. How does it work? Very simple. You can do it. Not in the kitchen, but you can do it. If you synthesize, if you make a specific oligo in the genome, you can synthesize oligo, another oligo, together with the commercial chip, make guide RNA in a day. Then, if you introduce this guide RNA into the genome, and together with the enzyme, it will cut in the place where you have divided. So, by using this, after that, the genome will repair. But what we want is to supply something in a way to repair with the modification we want to change. How? So let's say my neuron has a problem, overexcitation, too excited. Can I screen a drug to inhibit excitation? How can you do that? You can put, for example, a green fluorescence into an excited receptor. Now, when you make a stem cell to become neurons, do you have less fluorescence? Do you have less cells firing? Or they fire in not so excessive way? If you find any molecule, then you can work out how it works from a lead compound. Yeah, and one of my PhD students and worked on ALS. And he also found excitation is a problem for neurodegenerative disease. If neurons fire too much, neuron can die as well as a consequence. Can we find a molecule and for the similar purpose? She can also make iPS cell to become motor neuron. But motor neuron ALS, those patients, they die in 3 to 5 years without any treatment. So can you use those motor neuron as a replacement therapy for brain and for spinal cord? Meanwhile, screen for drugs which can enhance neurogenesis. I think one of my students that just graduated, who is going to work in the United States as a postdoc, and Ning Ge is in the audience online. I saw his name. What he did, he made a mini library of long QT heart disease with 20 people. And those iPS cells can become some beating and cardiomyocytes. So beating heart cells. Let me see now. When I saw beating cell on the dish, I gave up drinking, and I think I was to visit Papa and with my friend and coming from Donegal. I came back right to the lab and to see cells beating. Now, and can you add compounds to the beating cell to make them beat faster or slower? Will those be compounds? And further characterized for treatment of the cardiac diseases? Or can we make a sheet of cardiomyocytes? If they beat together, if my heart stop beating, can you rescue me with a sheet of heart cell? Can you combine with the compound from Chinese medicine for the treatment? These are ideas, needs further development. And Timothy O'Brien is interested in diabetes cells. Now, I can put this and after the insulin, insulin is the lack of insulin beta cells is a problem for diabetes. Now, can we make pure beta cell from stem cell for transplantation? And we can use this technology. Can we identify molecules which enable more beta cell differentiation or produce more insulin per cell? And these are the questions I say, okay, hopefully one day something will be there which was not there before. Cancer. You can remove cancer, but what happened afterwards? more cancer appear after years. What is the cause? Cancer stem cells. No drug. Can you identify a cancer stem cell new drug to kill cancer stem cell, but not normal stem cells? Now we have cancer stem cell. You can. This is one of the PhD projects we just started, and from September. These are all ideas, and we can do genome editing to make a space to have a pool of cancer stem cells with labeling, and we have iPS cells, normal stem cells. If we do drug screening, can we find a drug which is best to reduce either cell deletion or migration of cancer cells? If we can achieve one of them, we they either to reduce the tumor or less. Yeah, migration, proliferation, and migration is the key of the spreading of the cancer. From a few cancer stem cells, they can make cancer. Yeah. So this is, and of course we just touched. This probably has nothing to do with Chinese medicine yet, but making stem cell to kill specific cancer using genome editing, just like a lock and a key, like a natural killer cell. And you have heard CAR T cells make iPS cell to become natural killer cell to kill specific cancer. That's this student arrived just before New Year on 28th December. Genome editing is a very powerful technology. I'll come back, I want to say is we have to do it everything under ethical approval. And we need to do it wisely. You have heard a story about HIV and a twin they were born, which and has homozygous mutation on CCR5 gene. Why? That was out of goodwill, because HIV virus, when it's coming to attack cell, it requires a transmembrane protein. People with homozygous deletion of 32 nucleotides, encoding this part of the protein, they have no problem. They never get HIV. The idea is very simple. Now, if we make it make a mutant, and we don't get HIV, I think it's a good idea. Out of goodwill. Now, this is a sequence for this gene, CCR5 gene. The 35 nucleotide region here, I like it here. Now, when I do, if I want to edit, I had to look. Where can I find a guide on the sequence? I find that a good guide on the sequence which is here. But what happens is, look, there could be so many other chromosome targets associated with this. The best guide on I can find right there with DDD in the region of the 32 nucleotides you want to delete from there. So there could be potential of target effect. And for the genome editing, it's a boundary of, is it a treatment, is it therapy, or is it prevention? Where is the boundary? And this is an ethical issue. And I had watched this older movie a long time ago when I was a postdoc. It's called Minority Report. The idea is using someone floating on water, imagination, 20 years later, somewhere, and someone will conduct a crime. Police will go and catch it before the crime is conducted. That's prevention. But can we use genome editing as a prevention? Whatever we do, we must do it under ethical approval. So come back to summary, and for this lecture, Chinese medicine has benefited Chinese people for over 5,000 years. There are a lot more there to dig to benefit people in the whole world. And human stem cell and gene editing together can help, can speed up this process. But the library of the molecules, small molecules, must be constructed from herbs to enable the combination of this idea. And we have received already a small amount of over 2,000 molecules from Nanjing. So we can start to work on that. But this area, and we needed to propose to Chinese government as a research investment as well. And collaboration, not only Galway and Dublin, international collaborations are needed to advance this. And eventually combination of the Chinese medicine and the stem cell combinatorial therapy will be developed. And we believe, and such combination will overcome weakness of any single treatment and for our health. I want to thank you for being here and thank people who did this job. I'll take any questions we can discuss. Thank you.
非常感谢沈教授精彩又有趣的演讲。那么现在有请孔子学院讲师 Mario 来负责今天的问答环节。Thank you, Professor Shen, for the informative, comprehensive, and thought-provoking lecture. Now I would like to invite Professor Mario from the UCD Confucius Institute to take charge of today's Q&A.
Thank you, Rob. Thank you, Professor Shen. Like, wonderful lecture. You made it approachable also to us as you're in the humanities. So I learned a lot in this evening. So I want to open up the floor so I can see your question. Excellent.
Thank you so much for the lovely presentation, and it was a lovely presentation learning about it at a basic very level. One question I have for you is basically on genome editing and all of this. Do you see that there's a future for basically foreseeing genetic disease like sickle cell disease or Huntington disease or cystic fibrosis that can be cured before the baby is born and could be foreseen in the future way before when it's still as an embryo in the mother's stomach? Thank you.
Thank you. Thank you very much. And the gene therapy has been concept and for a long time, and even before this the CRISPR-Cas9 technology. So it is people's desire, and I tell you, if you want to do it, how to do it. My colleague and ex-colleague and from the same institute and Institute of Developmental Biology, we did master together and we worked together. He is in USA doing IVF. I went to see him during Christmas and New Year, and he has a mansion in Los Angeles, another one in UC Davis. Big business in America and in China, and doing IVF. And the prevention of the disease, there are several ideas there. One is if you have an embryo, let's say 4 cells, 8 cells, you take one cell to do genetic screening to find whether this embryo has a mutation. If this embryo has a mutation, and you don't, and transfer into mom's womb, yeah. And if this embryo is right and has no mutation, so that's a natural selection, because if it's a heterozygous disease, you may find some embryos they're perfect normal to start with, and you only need to transfer those normal embryo back, and then the mutant embryo, and you don't take back. And so that's one way to do it. That's acceptable to anyone. And if we, yes, the treatment, and I think it is under the way. It's gradually realizing by people probably we needed to do more, but there will be a control of its ethical approval level. Some genes and they can be rescued and in a way like we. So if this is a mutant, if this is a mutant gene, yeah, if the mutation is here, you can use this technology, so called CRISPR and Cas9. Cas9 is an enzyme which is going to cut, and the guide RNA is going to guide the enzyme to cut here. After cut, become two pieces. Now, if you supply a right sequence without mutation, when this chromosome is repaired, the chromosome replication comes from here, come over here, and take the DNA without mutation, go left way. And when this is done, what you need is to find out which embryo and has the gene, mutant gene being corrected. So I think that's the prevention of the disease. In a way, it's that way. And it's also it's a genetic therapy, which was more in the early concept, which is acceptable, but it needs tight control and approval and the process.
Other questions, please?
Yes.
I have a question, so to speak, about like treating adults, for example.
Yeah.
Like when you're editing like genes, to what extent does the scale go? Like when you're putting in a gene, you're putting, say, cells that could produce insulin into a liver. How does that get reproduced, or like what's the mechanism by which it would actually be an effective treatment?
That's a very good question. What we hope eventually we can develop like genetic therapy, gene therapy to work in vivo. And this moment we can deliver genes through like a virus, some and engineered virus, which has no harm to us. They can't replicate, but they can carry the gene you want into the cell, infect cell, then inject the DNA, which has the right DNA. And some of the diseases are probably on the way of the developing treatment quicker than others. Yeah, as you said, like diabetes, and we can make beta cell, then you can have a pocket of beta cells. And those cells will produce insulin when you're taking meal. And we hope that will last for some time. For type 2 diabetes is slightly different because it's not only the insulin amount, but also the resistance. But for the type 1 disease, you can have that temporarily to produce insulin. The problem with type 1 diabetes is it's called its immune system, our own immune system kill beta cells. So how to make beta cell last longer? And sometimes we require immunodepressants together with the cell transplantation. And for it's called blindness, and stem cell treatment has been developed. First clinical trial has been done in Japan. Take iPS cell, develop a sheet. It's called RPE, pigmentation sheet, grafted to the elderly patient, which has no harm, no side effect. But that was the first clinical trial from iPS cell to the pigmentation cells, RPE, and then into a human patient. And another one, I think that on the stem cell, the replacement therapy is the Parkinson. Why Parkinson? Because Parkinson has a very focalized lesion in the middle brain. Yeah, known cell type, dopaminergic neuron in a focalized area. So experiments were done on monkey already. If you graft dopaminergic neuron into the monkey of that lesion area, and monkey has the symptom have been improved. So that was done about 3-4 years ago. I think I will see gradually moving to for the human therapy, because that's also terrible. And one day, and I drove to Dublin, and I stopped and on the service, pop up petrol, and they had a cup of coffee. I saw a gentleman walked from this place to that place. Took him about 5 minutes to get there. So stem cell therapy was one of the disease, and with the fetal neural cells injected into the middle brain. That was over 20 years ago in Italy. And now, and if we can develop the cells specific for that and the dopaminergic neurons, and it's like a subtype of neuron we need for the treatment, and it might be helpful. Another disease is like for neuron brain disease, like ALS. And and Ola Harriman in Trinity organized a TV show. Either pour a bucket of ice water or donate money. He tried to raise money for the disease is called the amyotrophic lateral sclerosis. Because those patients, once they diagnosed, most of them, not everyone, most of them die within 3 to 5 years. No treatment. It's global motor neuron death. Those patients, they have no effective drug. They are happy to receive motor neuron. You can try out any, right? But of course, and it's not easy to make, and the cortical motor neuron, to make cervical motor neuron, make other areas specific motor neuron, which can connect it to the whole body. Yeah. So nothing is perfect at this moment, but now my student can make cervical motor with over 90% purity, mature, fire action potential. And so I think the next phase for such work is to do animal research. If we graft those motor neurons into animal model, will they help and the animals to survive for longer or ease their symptoms? And gene therapy come back is the delivery into, let's say I have heart disease, I have a mutation. Can you deliver CRISPR-Cas9 together with the right template to rescue or to genetically cure a few of my cardiomyocytes? And how many cells needed to initiate a normal heart function? Because the penetration can be a problem. It's not every cell can be exposed to the genetic material you are delivering. So maybe like a sheet of cured cells, cardiomyocytes already on the dish, if you can make a beating sheet, and which might be a better approach for this stage.
We have time for another question. We have hand up here. Yeah, then hand up here.
Okay, thank you, Professor, for today's presentation. And I was wondering, I'm very interested in regenerative medicines, and I'm still confused about how they work with stem cells. And also, I was wondering if there are any successful outcome that Chinese medicine is working together with the regenerative medicines. Thank you.
As I said right in the beginning, this seminar is not really a seminar, it's more like a proposal, how we can work together towards that goal. And we don't have, we just received a mini library of molecule, and we have 3 PhD started from September on different disease areas. We would like to combine to advance this, and by taking advantage of stem cell genome editing and the already small molecules we have received. And we would love to see identify one molecule, even just one molecule in 3 to 5 years. Either we can slow down the cancer cell division or migration. That would be wonderful. And so that is the development of Chinese medicine, or identification of effective molecules from herb. And in combination with stem cell and the idea, for example, like the diabetes, we will be able to make a pure beta cell. And in the next 2 years, we are doing gene editing right now. And we can also screen for over 2,000 small molecules we have received to see whether one of the molecules can increase the production of insulin or prolong the survival of the beta cells. If there is one molecule behaving that way, and we will hope to combine them for the treatment. But this is our goal.
So you mentioned Professor He Jiankui. So we know that he's very famous because he was sentenced to prison. Yeah. So was
He's out now.
Yeah, he's out now. So I'm very curious about this the article issue about genomic editing. So I would like to know your opportunity. Yeah. So what's your idea about this kind of issue? Yeah.
You mean about his case?
Yeah, in his case, yeah.
His case, I think he was a smart guy,
Of
number
course,
one.
yeah.
And he took it from the publication because of the mutation, homozygous mutation. People are free of HIV and disease. So taking action, and there was a demand probably from some rich people, family, and who want to produce baby healthy. And so I saw it from WeChat or somewhere, and there were some kinds of ethical approval and the process. And but probably, and he also communicated actively with people, experts in the field. Yeah, even before he was doing the work, or during, or even before the public announcement. But probably the news went out too early, and that was the one of the cause. And I think it's a case to highlight how important the ethical approval is. I don't say whether the system was wrong or he was in prison was wrong. It's our learning process. I think, and after 2 years, probably, and the field has moved on. The field didn't ban the work. They didn't use the word we ban to do this, but it will take time. Any new concept, any new area of development, sometimes we need to have a bit up and down, forward and backward. I don't know whether I exactly answer your question, but people also thinking, reasoning, and maturation will need time.
Yeah, thank you very much. Yeah.
Well, thank you, Professor Shen. I think it's a fascinating lecture. I have to say I learned a lot, although I wouldn't fully understand all of the, your research. However, as I'm getting old, I am
Me too.
paying attention to this aging problem for the human being. So, do you foresee any kind of possible solution or therapy through gene editing, genome editing, and through this stem cell therapy combination with the Chinese medicine altogether, that would actually not only find out the mechanism of the aging, but the therapy and the cure. So that means we would never die, all of us, especially at my age, whether I could wait for that day to come.
And we are all longing and to live longer and to live younger. And you probably will be happy to pay millions to exchange for another 10 years. If you have. And the problem is even if we have, we can't exchange it for use. But we are living longer. So this is a general question. It covers several areas. One is the aging, because other treatments are getting better. So, so infectious disease are cured, and most of them. Of course, COVID is for aged people is a problem, and there has been a problem in the last 3 years. And when we are getting aged, and some diseases are coming up, aged disease, and like Alzheimer's disease, more people develop Alzheimer's disease, which is slightly difficult to cure by stem cell, because we don't know which part of the new brain and has been more damaged. Probably it's widely, and the different area brains are shrinking. Drugs and the possible, and I heard, and one of the discovery in Zhejiang University, and which is hopeful for Alzheimer's disease. So that may not necessarily be from Chinese medicine, but it can be purified from one of the herb, maybe as well. And the another common disease is stroke. In my area, it's very common. My mom died of stroke, and my aunt died of stroke, and my dad had 2 minor episodes, although he is now still 95 and live on his own and able to manage it. Wonderful. But the stroke is getting so common. And the stroke is a blockage of the blood vessel. And if we don't, but then in surgeries and the effective treatment in the short time window and can help. And of course, if there are compounds which is going to dissolve, blockage in our circulation system, and more effective than drugs we have now, it may help. Another is cancer. Cancer, a lot of people die of cancer, and my supervisor, master degree supervisor, died last year in July of cancer. That's one of the things I'm learning myself. I'm not a cancer biologist. I didn't work on cancer before, but since I can now do gene editing, I teach students she's interested in cancer, Chinese medicine there. Can we find anything from the combination? So, and it depends on the disease, and some disease might be more hopeful. And if we can direct access, and some, like me, and I forgot was I locked the key, and when I went out home or locked the home, Alzheimer's disease, like probably more troubling to find the immediate, most effective drug. But people are working with it, and there is a hope too. Yeah. And we all have hope. And this adult stem cells are, like Timothy O'Brien is doing on clinical trials, and may help some of the elderly disease as well. Thank you.
谢谢大家。由于时间限制，我们的问答环节将在这里停止。如果你们还有问题的话，欢迎你们在论坛结束后与沈教授联系。Thank you for your questions, and due to our time restrictions, our discussion will stop here. But you are welcome to have a further discussion with Professor Shen after the forum. 感谢大家对本次论坛的支持，感谢沈教授精彩的讲座，同时也感谢主办方爱尔兰中国研究院和 UCD 孔子学院的有序组织。本次第50届孔子论坛圆满结束。Tonight we are so honored to have everyone here. Thank you all for your time, and once again, I would like to express our gratitude for Professor Shen, and to the organizers of the Irish Institute for the Chinese Studies and the UCD Confucius Institute. The 50th Confucius PhD Forum has come to a successful ending. 学院为我们准备了丰盛的中餐自助，但由于我们的工作人员正在准备，所以请大家稍等片刻。然后the college has kindly prepared a